Hey, what is up, ladies and gentlemen, boys and girls? Welcome to another episode on the Incredible Academics YouTube channel. Guys, look, today we are going to be discussing sum to infinity, which is just another subtopic under geometric series, right? So that's what we're going to be looking at shortly. And I hope you guys are ready. So the date today is the 29th of December 2023, right? And yeah, so sum to infinity. Okay, so remember when we were using the formula, Sn is equal to n over 2 into 2a plus what? Plus n minus 1 times the d, right? Okay, this was for arithmetic, right? Arithmetic, fine. And then also we had what? Sn is equal to n over 2 into a plus the last term. Right, this is what this is still arithmetic when the last term is known. Okay, all right. Also we had what? So for geometric, this is what we had. The sum of any number of terms n, right, is what? A into 1 minus r to the n divided by 1 minus r, right? And we also spoke about the fact that, so this is geometric. So we also spoke about the fact that when r is between so r is between minus 1 and 1, and then we have convergence. In other words, the series is going to converge to a particular number. All right, it's going to converge. In other words, it's going to tend to approach a particular number, right, as when we keep on adding the terms. So for instance, let's say maybe after term number 50, right, you find that even if you say, okay, let's compare term number 50 and the sum of 50 terms and the sum of 55 terms, you realize that, nah, man, these are kind of like giving me almost the same number. And then you try to check the sum of the first 60 terms. You realize that, no, man, these sums, they kind of like give me almost the same number. Do you understand? And what is actually happening in that situation is that now you're starting to have convergence. In other words, that the sum is sort of like converging to a particular number. All right, so, and that situation can only occur when you've got your r being between minus 1 and 1. Okay, so now while we're still talking about a series that converges, then we have to build up on that. In other words, we sort of like going to extend from that. In other words, we're going to talk about series in the context of of convergence. Do you understand? Now we're not really gonna talk about the series that does not converge. Okay, so we're going to talk about the series that converges. So whenever you've got a converging series, right, then you can start talking about sum to what? Sum to infinity, right? Sum to infinity. In other words, if you want to see what is it that this sequence is going to converge to, and then you find the sum to infinity. Do you understand? So in other words, it must already been established, that your series has got its R lying between what? -1 and 1. Then we can start talking about its sum to infinity. Do you understand? In other words, what is the value that our series is going to converge to, given that it does converge? How do we know that it does converge? When we've established that the R is between -1 and 1. Okay, fine. So sum to infinity. So remember, a finite sum for a geometric, because also we don't talk about sum to infinity when we're dealing with the two. So these formulas are specifically for a finite number of terms. In other words, we need to have a particular value of n in order for us to be able to find the sum. And if we don't have the n, then we can't find the sum, right? But with a geometric series, whenever we talk about sum to infinity, just know that we are referring to a geometric series. Okay, there's no sum to infinity for all the other types of series. In fact, just for arithmetic, just know that we don't have sum to infinity. So how do we calculate the sum to infinity? So let's suppose that we are given this. We are given this n from 1 up to a certain large number. We don't know exactly what the number is. And then we're also told that we've got 5 into 1 over 2 to the exponent n minus 1. So that's like the series that we're given, okay? And you're asked to evaluate, okay? So normally we'd say, okay, cool. What we're going to do is we're just going to run a quick check. This, because of the base and exponent, this must be geometric. Therefore, we're going to use Sn is equal to what? A into 1 minus r to the n over 1 minus r. That's what we would normally do, whenever we're dealing with a geometric series. But because we don't have n at the top, there's no last term, okay? In other words, here we're dealing with an infinite number of terms, right? So before we're dealing with a finite number of terms. In other words, this one here, it's for a finite number of terms. In other words, when using this kind of formula, we must know exactly if we've got the last term, right? So if we don't have the last term, we cannot use this one, because immediately when you say sum to infinity, that means we don't exactly know what the last term is. Do you understand? So finite number of terms, you use this formula. But infinite number of terms, infinite number of terms, you're going to use a slightly different formula, which says sum to infinity is given by a, which is the first term of the series, over 1 minus what? The r. Okay? So where the r is an element of minus 1 to 1. Okay? And I want to make it very clear. This does not say that r is either minus 1 or 1. This tells us that r can be any number which is between minus 1 and 1. And meaning that minus 0.99, minus 0.89, minus 0.75, which is minus 3 over 4, minus a half, minus minus 1 over 4, you know, like those numbers, they are still within this interval here. 1 over 2, 3 over 4, 0.97, they're still within this interval, right? But r cannot be exactly -1, exactly 1, then that would diverge. Do you understand? So this is the formula that we go to use. So this is literally the thing that this entire video is about. Sum to infinity is given by a over 1 minus r. So if you've missed, you know, everything else that I've said, make sure that this, you bear it, you know, in the back of your mind. Like it must stick, because that's the most important thing for this video. So sum to infinity is given by the first term of the series over 1 minus r. Excellent. So this is what we have, the new formula. So meaning that whenever you're dealing with a geometric, you know, series, you need to ask yourself, is this series finite or infinite? Because the formulas are not the same depending on the type of sequence you're dealing with. I mean, the type of series, sorry. Okay, so if it's infinite, this is what you use. If it's finite, you use this formula here, right? When it's finite, in other words, when there's a last term, okay? And how you know that there's a last term is when there's some value at the top. So n is equals to 1, to 5, or any other number, as long as it's given, of 5 into 1 over 2 to the exponent n minus 1. To understand, we know for sure that the last term is term number 5, okay? But as soon as it becomes like this, sum from n is equals to 1 to infinity of 5 into 1 over 2 to the exponent n minus 1, we know that now this is a different kind of problem. Why? Because it's a sum to infinity. So now let's look at this problem quickly so that we can apply the formula. First term, to find the first term, t1 is basically equal to 5, 1 over 2, 1 minus 1. So basically we've got 5 as our first term, right? And the r is basically the base, which is what? 1 over 2. Okay? And you can see that the 1 over 2 actually lies between -1 and 1. In other words, we have got a converging geometric series. Do you understand? It converges. In other words, eventually it's going to come down to a specific value. Yes. So in other words, it's not divergent. It's not gonna give you different values as when the n gets larger and larger. Do you understand? Yes. So we've got the a and the r. So t1a is equal to t1, and that is equal to 5, and that's all we need actually in order for us to be able to find the sum to infinity. Okay, so once we've got the a and the r, then sum to infinity is given by a over 1 minus r. That's it. And r needs to be between -1 and 1, and we've confirmed it that it is actually between -1 and 1. So 5 divided by 1 minus the r, which is 1 over 2. So our answer is going to be just 10. In other words, as the n value, right, the number of terms get larger, we are going to see the sum, you know, converging to a value of 10. In other words, our sums are not gonna, you know, be that different from the number 10. Eventually, no matter how large the n is, you're going to see yourself getting a value of 10. So that's the first problem that we have looked at. So let's look at another problem. So we're given the sum, right, of from n equals to 1 to infinity of 3 over 10 to the n, 10 to the n, okay? And we have to evaluate. Okay, because sum to infinity is very easy, okay, because all you need to do is identify the r and the a. That's it, no complications. Okay, once you've got the r and the a, it's done. So meaning that you need to be very good when it comes to expanding this whole sum. So the first time we just put 1 by the general term, so it becomes 3 over 10 plus 3 over what? 10 squared, that's 100, isn't it? 3, and then 10 cubed, that's 1,000, isn't it? So on and so forth. Now this goes on forever. That goes on forever. So now you need to identify the r. Where is the r? Alright. The r, remember, the r, you can simply take the second term divided by the first term. So 3 over 100 divided by 3 over 10. That's how you find the r, by finding the quotient of any two consecutive terms. Right? 3 over 100 divided by 3 over 10. And that is just 1 over 10. So our r is 1 over 10, and obviously the a, that's just the first term of the sequence, which is 3 over 10. So now sum to infinity. So once we've got the a and the r, then we're ready to find the sum to infinity. Okay, so sum to infinity must be given by what? A over 1 minus r. So a is 3 over 10 divided by 1 minus 1 over 10. And obviously the series converges because 1 over 10 is actually between minus 1 and 1. Okay, you must be on the lookout for that, because one day you will be asked, does the series converge or diverge? All right, so 3 divided by 10, 3 divided by 10 all over 1 minus 1 divided by 10. So our answer is 1 over 3. So that's the sum to infinity. All right, that's the sum to infinity. And let me see if there isn't any other problem that we can look at, but I'm seeing this problem here, which looks very, very interesting to me. So we've got this sum over here, sum n is equal to 1 to infinity. Once they say infinity, we already know what formula to use. 10 to the exponent 1 minus n, 1 minus n. Okay, now we need to find the sum to infinity. Does it exist? Does it not exist? Okay, we're about to find out. So really the thing that you want to do is you want to first expand your sum, maybe just the first 3 terms. Okay, so we know the first time we just put a 1 there. 10 to the exponent 1 minus 1, that's 10 to the 0, which is just 1. So plus the second term, that's going to be 10 to the exponent 2 minus 1 minus 2, which is negative 1. So that becomes 1 over 10. All right, 1 minus 2, that's 10 to the exponent negative 1. And then becomes 1 over 100. Okay, yes, and then it goes on like that up to infinity. All right, so when you have expanded your series like this, it becomes way easier for you to then find your r, because you just take the second term divided by the first term. I mean, anything divided by 1 is, anything. All right, so 1 over 10, that's our R, and our A is just 1. Beautiful, isn't it? So because it says sum to infinity, we know, for sure that the formula is going to be sum infinity is equals to A over 1 minus R. All right, then we do the substitution. Our A is 1, our R is 1 over 10, which is between minus 1 and 1, meaning that the series actually converges. Okay, so punch everything into the calculator. 1 over 1 minus 1 over 10, and the answer is 10 over 9. Ladies and gentlemen, we have come to the end of this video. I hope you guys enjoyed it, and all the best. Don't forget to like, subscribe, share with friends and family, and peace out.